Thank you for joining us today. I'm pleased to introduce Shri Subramanian, our Senior Director of Product Management, and today she's going to talk to us about why your next generation branch firewall should be cloud firewall. Thank you so much, and with that, I hand it off to Shri.
My counterpart in product marketing, and as she said, I'm going to talk about a cloud firewall, but essentially what I'm going to present is how you can securely transform your network. And I'm very aware of the fact that transformation is a very overloaded term and can mean a lot of different things. So I want to clarify what I mean by that. What we want to talk about is how you can embrace cloud applications in a secure way. And that's what transformation is in the Zscaler context. It's enabling our customers to be able to adopt and embrace cloud applications, whether it be blessed ones like Office 365 or it might just be ones that your users are using. We started a few years ago, and the premise at the time, which has borne fruit now, was that the network as it is designed is essentially a sort of a hub and spoke model where everyone who's inside the office and all the machines are inside the office and they're all connected and there's sort of a gate around them, and therefore you control traffic that's coming into your corporate network and going out of your corporate network. The problem that it presented was we started seeing more and more applications moving to the cloud, either because there were applications like Salesforce.com that were being adopted by various departments inside the company, or maybe the IT organization was moving some of their legacy applications to Azure or AWS or one of those kind of platforms. In addition, users were no longer tethered to their desks, which meant that users would, the gravitational force took the access between the user and the application outside the network. You just directly access the network when you're at home or in a cafe or somewhere else. And that poses a challenge of how are you going to secure that traffic that is not even part of your corporate network, that's not passing through your corporate network in any way. There are two solutions we built. One was for what we call the inbound gateway, and one is for the outbound gateway. So the first solution is for the outbound gateway, that is ZIA, which is Zscaler Internet Access. It allows users to access applications that are in the internet in a secure fashion, and that's the one that we'll be focusing on in today's webcast. And we've also built a inbound gateway, which allows users to access their private applications, whether they be in your data center or they be in a private network on Azure or AWS or Google Cloud or somewhere else. But essentially, it extends the model that we have for cloud applications to also your private cloud applications or private data center applications. One of the things that we all always hear about in every analyst has talked about it, it's there in every forum, that when you access cloud applications, you need to be able to allow direct access to the internet for these cloud applications. And that's because cloud applications and all internet applications often are CDN or data operator based. They have different POPs in different places. You want to optimize where you access these POPs, and you want to be able to access something that is closest to you, get the best user experience, whether it be latency or in some cases it might even be in Europe, it might even be the country and the language and the localization that you get because you're accessing a POP that's close to you. We all understand this, and I think a lot of customers who might be adopting a web application or a web-only application might assume that all they need to do is break out their web traffic, and that is not true. And so I want to kind of walk through some of the scenarios of the type of traffic that needs to be broken out in order for cloud applications to work. some cloud applications are web only, and some cloud applications are a mix of web and other kinds of traffic. So in this scenario, we're going to just draw a hypothetical scenario. I am the user, and I'm in San Jose, and I'm working for a company that has a headquarters, let's say, in Atlanta. And I'm trying to access one of the cloud applications, whether it be Box.com or Google or Office 365, it doesn't matter. I'm trying to access something. In this scenario, it's still a web application, so I'm just trying to access a web-only application. And my company has broken out my web traffic, but not the rest of my traffic. So I go to my browser and I type Box.com. And what happens is that the browser generates now a DNS request for Box.com, which, because I've not broken out any of the DNS requests, will go to my internal DNS server back in the company headquarters and then break out from there. And what happens as a result is, because the DNS request is going out from Atlanta, I get placed to a POP which is very close to Atlanta. What this then means is that I am actually accessing on a very slow connection a Box.com server that is very far away from where I actually am. If there could be a breakout of DNS, then I would be actually accessing a POP that is very close to where I am. There are some situations where a breakout of DNS specifically might be hard to achieve. We still recommend that you do the breakout from the closest places that you can where you have local resolvers. And we are in our roadmap, and we can talk about that in a roadmap session, building more solutions to work for customers who may not have local resolvers in different places. So if you are interested in learning what we're doing, we do have a beta coming up for that feature, and we'd be happy to talk with you. So please just drop a note to either Jen or myself. My email address is sri@zscaler.com.
Mine is jtoscano, JTOSCANO @zscaler.com. And Shri, part of why I jumped in there was we have a question, and it was, so can you share a local server folder via this Zscaler private access, just like we can do via traditional VPN?
Yes, you can. So the Zscaler private access can access any type of application. It's an L3, L4 type of access. So you could be doing file shares through that. Now let's look at another application, one that is actually a mix of web and non-web. So today we are on a WebEx, and that's one of those kind of applications. Skype is another. What we do when we access WebEx is we go on a web page, we type our name and other things, and after an HTTP request, we hit join, which launches an application that then establishes a video stream that is on a UDP port. So your first web access would still go to the closest POP. The closest POP is going to then figure that you are actually in, or I am in this case, in this hypothetical case, I am in San Jose. That means that I need to be accessing servers in San Jose. It will actually make sure that all of my connections are established to servers in San Jose at that point. So that's one of the reasons why they ask you to come to a web application and then set up things. And then a video stream is set up on a UDP port. I think it's 9,000. And unfortunately, now that UDP stream is going back to your headquarters and coming back on a very slow connection to a local server because the UDP traffic hasn't been broken out. So essentially, if we could just break out all of our internet traffic, anything that is going to the internet just gets broken out from your branch or from your location, from your headquarters, wherever you are, wherever users are, you take the traffic and you say anything that's going to my data centers goes to my data centers, everything else gets broken out and sent to the Zscaler cloud. You will end up actually accessing applications in the most efficient way, because we take care of making sure that you are getting placed to servers that are close. Another way to look at it is how the security world has evolved over the years. So we started with technology called the firewall. And the firewall was essentially built ground up to protect servers that were behind a firewall. And the idea was that you know what kind of traffic the server is expecting. So if there's any traffic that doesn't look like specifically the type of request that you might send to the server, then block it. So firewall is actually steeped in access control. Access control is a very, very, very important part of firewall. That is the core functionality of a firewall. As time went by, we started having users who were accessing servers on the internet. You don't really know what servers are out there. You can't really figure that out. So a new technology was built. This was called the proxy. And what the proxy did was it actually looked at HTTP, HTTPS type of requests and responses, and then scanned them. So there is some access control in terms of URL filtering, but over and above the access control, there's a lot of focus on decrypting SSL, on looking inside the traffic, doing those kind of things that actually make it a little bit slower. In the traditional proxy was a little bit slower than a traditional firewall was. So you might be able to get a lot more throughput from a single firewall than you might be able to get from a traditional proxy. And the proxy also technology was very web focused. And so when applications started emerging that were non-web, we started sending all of that non-web traffic again through the firewall, but just in the reverse direction. And what that has done is now your applications were split across two different devices. Your logs were split across two different devices. So the way that we countered that was we actually stacked these two devices in line with each other. So the traffic that was going directly to the firewall just bypassed the proxy and went there. But the traffic that was going through the proxy went through the proxy and then went through the firewall, so you could have one place where you could get that consolidated log. As you move to the cloud and you're moving your proxy solution over to the cloud, you can't really be stacking those two together in that fashion. And also in the cloud, you get infinite elasticity, so capacity isn't actually a problem anymore, and speed isn't actually a problem anymore. So the better model is that you leave the firewall doing what it was designed to do, which is inbound traffic into your data center, and take all of your outbound traffic, no matter what port it is, and send it through the Zscaler cloud firewall, which is a very integrated version of a proxy and a firewall, and therefore has certain inherent advantages that we'll talk about later. So essentially what we're saying is go back to a model that was clean, where you have inbound traffic going through a separate device, outbound traffic is going through your cloud, and now you have better logging of all of the traffic and better ways to look at it. One of the big applications that a lot of our customers are adopting is Office 365. And I take that only as an example over here, but it's a great example of why and how Zscaler really works for all traffic. So Office 365 isn't just web traffic. There is, like we talked about, there's Skype that has UDP traffic, there's DNS, there are other pieces of Office 365. And let's look at how it works in an integrated fashion. This has a summary of various reasons that you want to be using the Zscaler cloud, but we're going to go through that. I really want you only to look at the picture, which there are a lot of applications, and really Office 365 is just an example that we're taking here in terms of why and how the Zscaler cloud works for an application such as Office 365. There are essentially four big advantages that we provide. One is that we're paired with Office 365, and that makes your access to Office 365 not two hops when you're going through Zscaler, but essentially just one hop. We also have a scalable cloud firewall, an elastic cloud firewall. Now, this is very important because surveys show that about 65% of all customers who are going through Office 365 transformation end up actually upgrading their firewall, because there are a lot of issues with Office 365 and firewalls. And most traditional on-prem firewalls aren't designed for that kind of scale. And so you end up investing in them. And of those, about 60+% don't actually get any benefit even after they have spent the money on their on-prem firewall. So the elasticity of a firewall is extremely important when you're going to applications like Office 365 and your traffic is increasing. In addition, even though there's only one hop essentially to your Zscaler cloud, that is an optimized TCP stack. So you will see how that is giving you actually faster file downloads than you would if you went directly to an Office 365 POP in many of the situations. And we'll give you more details about that too. And the last one is, no matter how elastic the cloud is and Office 365 is and Zscaler is, you have a certain bandwidth at your egress point, and you want to make sure that your business critical applications are getting priority on the queue at that egress point. And how do you do that? And we have a product called Bandwidth Control to do that. So we're going to talk about cloud firewall, but really we're going to talk about the full solution first, so you understand how Zscaler works end to end. So here, a sample of locations. I think there are about 20 locations now that we are paired with Office 365. Everything that's marked in the Microsoft red is actually a paired location. And that means when you are getting to that location, we're just a hop away, like a millisecond away from an Office 365 POP, which means that you're really essentially accessing Office 365 almost directly. The scalable cloud firewall, the features of this, it is a typical firewall. It has stateful firewall policies that it can support, like IP address, ports, protocols-based policies. It has the standard next-gen firewall policies, which include app ID-based policies and user ID-based policies using our deep packet inspection engine. It has the ability to do fully qualified domain names. All of these we will kind of spell out a little bit later in this webcast. But the more important thing here is the cloud-related advantages that you get. So because you are accessing a cloud-based application, it means that you're accessing essentially the same capabilities no matter where you are. And because you are doing that, you also don't have to have a central manager, a logging service, everything separate that you have in your traditional firewall situation. So let's understand that just a little bit better. So before we go there, what the cloud firewall is helping you do is essentially get off that hub-and-spoke model, which you're forced into because you're trying to invest in firewalls. And the truth of the matter is the bigger boxes are actually cheaper than multiple smaller boxes. And so that's one of the reasons that we ended up with this hub-and-spoke model. In some cases, people do use UTMs and do breakouts, and that has its own challenges. And in both cases, we'll talk about the challenges in a little bit, but essentially it helps you break out without having to have any appliances. So let's talk about a scenario where you do have, different egress points and different appliances in different places. What that means is, you're not going to buy the same appliance for a 10-people sales office you have in Paris as you might for your headquarters, let's say in London or New York. And so essentially what you end up with is different appliances. Even if they were from the same vendor, you end up with different appliances at different egress points. And this means that you have capability, let's say, to do 100,000 policies in one of the appliances and capability to do about 10,000 policies in another. They both have the same features. They both can do next-gen firewall type of policies or stateful firewall type of policies, but they have essentially different capacities, whether it be in terms of signatures or it be in terms of policies. And what that results in is that you end up having to logically figure out how to compress your 10,000, how to compress your 100,000 policies into 10,000 meaningful policies for this smaller location. And essentially what that then ends up with, what you then end up with is a sort of a management platform where now you can look at policies across different locations. You can understand if a policy is actually, which locations the policy is applied to. And that complexity then implies an additional license of a management platform. On top of it, either the management platform is extended to, or there's a separate logging and reporting platform that you need, because all of these devices, because they are all different locations, it doesn't make sense to be logging in those devices. So therefore, the vendor doesn't even provide a whole lot of logging space in those devices. They provide capability for you to stream the logs out from those devices into your own drives that you have to now maintain, you have to size, and you have to collate those logs. And then you have the complexity of the identity management server. So you can see the cost and complexity multiplying very quickly in this scenario. So let's first eliminate those appliances, which are each expensive. If you have, let's say, a 4-people office, you're not going to be able to buy an appliance just for 4 people. You're going to buy the minimum appliance, which is, let's say, 25 people. And then, do that for every one of those locations. You start adding up the cost. Just the appliances can be very expensive. So the first thing that Zscaler allows you to do is eliminate appliances. You pay just by the number of users you have with no extras. The second thing is you eliminate all of those extra servers and management consoles and logging consoles that you had, because you get a built-in single management console at no additional license or charge. You get a built-in logging infrastructure, which includes all of the storage space that you need for logging. And there are no compromises in the type of logging that you have. When you are doing a lot of logging and your traffic is also growing, you end up oftentimes having to make compromises and say, I'm just going to log the blocks in this location or things like that. And you don't have to do that, because we guarantee, there's an SLA guaranteed logging for every single session for 6 months. So you end up with no security compromises, no logging reporting compromises, and a single management console. And your branches or your user segments in your headquarters basically get simplified. Essentially, all of the users are behind just a simple router that doesn't take any incoming connections, because you have no servers inside that network segment. So you can just block all of the incoming connections. Anything that's outgoing connection from the user to an application goes essentially in 2 directions. It either goes towards your data center, or it goes default route to Zscaler. And remember, in this webcast, we're just only talking about ZIA. That left arrow could also be ZPA, which is our private access, but that would be a separate webcast. So for now, let's just keep that as whatever your solution is over there. And then default route for any internet connection just goes through Zscaler and gets processed there, irrespective of port or protocol. Now let's look at why elasticity is so important even without Office 365. This is just normal increase in traffic that we see across our customers. In 2 years, there's about 150% growth. And with Johnson Controls, we saw 150% growth just in 1 year. So that's like amazing growth that you are looking at in terms of just traffic, internet traffic. When you buy appliances, you will have to plan for 3 to 5 years, which means you are going to have to buy capacity that accounts for this amount of traffic growth, and therefore you're buying capacity that you're not using today. Again, going back to the Zscaler model, it is based on number of users, and so you essentially don't pay anything extra for that extra bandwidth as it grows. Zscaler Cloud expands for that, and because as we get more traffic, we also get more cost savings. We sort of amortize all of that, and so therefore no cost increase for you just because of your increasing bandwidth. That elasticity also is what causes a lot of firewalls to keel over when you go to Office 365. which is why a lot of our, a lot of the customers actually end up having to upgrade their firewall capacity. What happens is Office 365 wasn't really designed ground up for the internet. So there are a lot of long-lived connections per user, sometimes, up to 20 connections per user. And firewalls are, there's a port exhaustion that happens when you have that many connections that are just there like the whole time. And so what happens is then users basically those connections aren't getting passed properly. The users end up seeing some random hangs and connection issues, and basically they have to restart Outlook in order for them to start for Outlook to start working, and that is a painful experience for our users, and that ends up with more money spent on these firewalls that again have scaling issues. As you keep going, there are going to be more and more scaling issues just because your traffic is going to increase. Not just your Office 365 traffic, which we'll see in a bit, is also increasing very quickly, but also your other traffic is going to increase. With an elastic firewall, you get as much capacity as you need, and there are SLA guarantees on that. This is the increase in Office 365 traffic that we saw in the first 2 years that we actually introduced Office 365. You can see that traffic grew 10x in 2 years. Now, some of that was because of new customers coming on board with us, and some of that was because of customers' Office 365 traffic actually increasing, either because they were rolling out or just because, they started using more applications or so forth. Now, remember, Office 365 is an extremely chatty protocol, and that means that traffic grows very quickly with your number of users. The other Office 365 feature that we have, I talked about the TCP optimization. So when you are accessing our cloud, you're actually a little bit faster than if you were to go direct to Microsoft. And that seems a little bit backwards. So let me explain how that works. A typical TCP connection is assuming that a lot of the traffic that's coming is HTTP, and therefore, the way that it works is it's designed to take small packets. And for a very long time, the window size on the TCP connection is going to stay small, and only when it starts seeing that, that window size isn't working, then it quickly sort of ramps up the window size exponentially. Now, there's two problems with this. One is, initially, for a long time, you're just staying with a small window size, even though you actually need a bigger one. And the second is, it ramps up so quickly, but it doesn't scale beyond the 3 MB, and then on top of it, it's trying to find that sweet spot, and then when it ramps down, it also ramps down very quickly. So it's kind of like going, yo-yoing up and down. Instead, what we do is we actually start with a slightly bigger window size. So we start off knowing that, look, these are, oftentimes file downloads, you actually need a bigger window size. And then we do a sort of a step progression, so we can actually stop where the window size makes sense, and we can also scale to a much larger window size than a typical TCP connection. What this means is we had an Office 365 instance in Iowa where we uploaded some files. We then went from, this was a third party that did all of the testing, but they went from Atlanta, Chennai, Chicago, Frankfurt, Hong Kong, London, Miami, Washington, D.C., basically from all different parts of the world where we had peered Office 365 connections, and tried to access through us the same Office 365 shares, or access directly the same file and download it. And we measured two things. We measured the file download time. We also measured the DNS resolution time. And in both cases, this is what we got. For the file download, we got about a 40% faster download. Now you can see that the Office 365 files were located in Iowa, so the file download from Chennai is obviously longer. But you can see that going direct was way longer, almost 8.5 seconds, versus going through Zscaler was a little bit, less than 5 seconds. So it was 4.6 seconds or so. Same for Frankfurt, same for Chicago. Like every one of these locations, you can see that there was an optimization for going through Zscaler versus going directly. Now, if you had a location in Sao Paulo or someplace where we don't have a data center of our own, and you go through us and you go through Office 365, you may not see the same 40% faster download speeds in those situations. It might be very similar download speeds, but certainly in a lot of locations, there is a speed increase that you see by going through us. The same thing for DNS resolution. We were about 8 times faster for DNS resolution in a lot of these locations. It was amazing to see how fast we were in almost all of these situations. The full report is available at catchpoint.com/resources, and this deck, I think, will be shared back with you, so you will have access to it and you can look at that full report for how our TCP optimization actually helps you with your Office 365. And the last part of what we provide with Office 365 is our bandwidth control, where we actually you can configure policies that say, for example, when you have a lot of YouTube traffic and that's going to take a lot of your bandwidth, you could have configured policies that say that you want to guarantee 40% traffic for Office 365. So you can see the pipe on the left just got throttled. None of your connections actually drop. You still see the same YouTube video. You just see more pixelation on it. And your Office 365 traffic doesn't stall because of it. The policy that we recommend most customers go with, we have 2 types of policies. What we call a min policy, where you can guarantee traffic for, let's say, an application like Office 365. What the guarantee means is that you have Office 365 traffic. When you have Office 365 traffic, it can take for up to 40% without getting throttled at all. However, when you do not have Office 365 traffic, your YouTube or other applications can take all of that bandwidth and work through that. The left side is where you can cap the traffic. Let's say you have YouTube traffic, you can cap it at 50%. That means that under no circumstance would your YouTube be able to take more than 50% of your bandwidth. So if you had a 1 gig pipe, then it would not be able to take more than half a gig. This is not a policy that we recommend in most situations. It is useful in situations where you might be paying by bandwidth, either in a tiered or a pay-as-you-use kind of model, in which case you might want to cap some of your traffic. In any case, this totally absolutely helps when you are doing your breakouts and you want to make sure that your mission-critical applications are getting priority as needed. So here's the customer use case. Kelly Services is a company in Michigan. They have offices globally all over the world, and they were, looking to see how they could move to Office 365. And they looked at the hub and spoke model of backhauling all the Office 365 traffic. And this is pre the days when Microsoft started giving very clear guidance not to do that. Very clear guidance not to go with Express Route. I think recently they've even come up with a blog post that says, if you are going to use Express Route, you need to go through a review process with us, because that's not how that application works. They were looking at it, and just the cost of doing that would have just been a lot because of all of the firewall upgrades that they would have had to do in order to support Office 365 traffic. And then they looked at the branch firewall UTM model and the number of different things that they have, number of different sites that they have, and the amount of time it would have taken for them just to update rules for every one of those sites was just enormous. On top of it, they would have ended up with differing capabilities in each location, as we talked about, and the complexity was too big to manage for them. So they ended up choosing us. They have a cloud firewall with Zscaler, and they configured policies over there. They found that they actually reduced their rules that they had from about 600 plus to about 10. They're now back up to about 50 just because of the number of applications that they've added since then. But really, they found like a huge reduction in the number of policies they needed to have. They simplified their rule set tremendously, and they were able to deploy very fast, about 10 sites per day for week 1, and 25 sites for week 2 to 4 was how fast they were able to deploy their cloud firewall. They also got bandwidth controls, and that they actually did cap their YouTube traffic at about 20%. They felt that there was a lot of abuse of YouTube traffic, and they also guaranteed about 40% bandwidth for Office 365 during the period of contention. You can see that we have actually a growing set of Office 365 customers, and a lot of Office 365 traffic, over a petabyte of traffic actually goes to us per month, and it is growing very fast. Like we talked about, it's about 10x in 2 years is the kind of growth that we're seeing with our Office 365 traffic.
We had a question.
Yeah.
Are IPsec GRE tunnels required to get the traffic to Zscaler?
Say that again, Jen.
Are IPsec or GRE tunnels required to get the traffic to, or I'm sorry, IPsec or GRE tunnels required to get the traffic to Zscaler?
Yes. From your locations, you will need to establish tunnels to get traffic to Zscaler. We had a little slide over there on the top. Let me go back to it, where we show you that all you need for that tunnel to do is to say default route to Zscaler. Basically, on your router, you decide what traffic needs to go on your MPLS, and everything that is going to Zscaler, you then encapsulate into a tunnel and send to Zscaler. All ports and all protocols is our recommendation.
Great, thank you.
Okay, let me go back to the other thing that we see a lot of customers doing is SD-WAN. There is a lot of excitement about SD-WAN in the market. There is an expectation that by the end of 2019, 30% of customers or enterprises would have developed SD-WAN technology in their branches, which is, a huge leap from the 1% that's there today. And that's a market that's expected to grow. So if you are thinking about SD-WAN, there are multiple reasons that customers go with SD-WAN. But one of the things that SD-WAN also allows you to do is it allows you to do the breakout very easily. However, when you do the breakout, you also want to make sure that your breakouts are secured. So by going with Zscaler first and making sure that you have a cloud-based security model, it allows you then to break out from different locations and not worry about security, because you're getting the exact same security everywhere very quickly as you break out. So every appliance vendor, when you do this breakout, you're starting to go with branch appliances. Every appliance vendor is going to want to have an appliance in all of these places and all of that extra that we talked about, right? And then when you start adding more and more appliances, you can see that that gets really, really complicated and really good for your appliance vendor. With Zscaler, you have your SD-WAN routers. You don't need any appliance in any of those situations. What you need is the ability to then direct the traffic that's going to the internet to a Zscaler cloud. And there are simple ways to do that. Essentially, what you want is to separate out your trusted network, which is inside, and your untrusted network, which is the internet. And anything that's going to the internet basically just is going through a tunnel to a Zscaler cloud, and that tunnel is IPsec or GRE. You want to make sure that in all of your locations you have two tunnels, two separate Zscaler instances. You might do that from two separate routers, two separate SD-WAN routers, or you might do that from a single router. And if you didn't have SD-WAN, it's exactly the same. You would still want to have two tunnels, and you might do them from separate routers or from a single router, depending on how your location is set up. But essentially, you want to have a backup tunnel to a different Zscaler location just for situations where maybe there is some sort of an issue either in the path to Zscaler or the Zscaler cloud is going through some sort of a DDoS attack or something else, and you want to make sure that there is a fallback path for you to a different location. So again, we talked about the breakout, but let's talk a little bit more about cloud firewall specifically. And let's understand the difference between a traditional firewall and a cloud firewall. And we talked about the elasticity of the cloud and some of the cloud effect that you get, and the simplicity of the policies and all of those. Let's just talk about core functionality. A traditional firewall doesn't actually terminate your connections. It doesn't have a proxy. It's not based on proxy-like architecture. So you can think of it almost like an X-ray machine, that when a package comes, it can look at it, it can smell it, it can X-ray it, and it sends it through if it looks okay. If it doesn't, then it basically then decides to block it. However, Zscaler Cloud Firewall, because we have the ability to actually inspect deeper, because we actually have the ability to terminate connections, whether they be HTTP connections or DNS connections. And in fact, for HTTP, we can terminate HTTP because our DPI engine will look at a connection that might be coming on a high port that's really HTTP. And a lot of the signatures that you see in IPS are actually for those kind of things. The reason is that hackers are constantly trying to find open ports to send out their command and control messages. They send it through the proxy first. If the proxy blocks it, they try it through the firewall at a different port. So we can actually detect those. We will terminate the connection, open the packet, look at it, do all of the inspection on it, and then repackage it and send it out. So remember, when we talked about firewall and proxy, the proxy architecture is much more security focused. The firewall architecture is much more access control focused. So while proxies have built some access control in terms of URL lists, and firewalls have built some security in terms of signatures, the signature-based methods can only take you so far. And so the additional functionality that you get in a cloud firewall, in a Zscaler cloud firewall, is that you actually do get to inspect a number of protocols. And going forward, we're already adding another protocol in our 5.5 release. And then going forward, we'll have more protocols that we will actually be proxying. What this means is that because we are scaled to be able to do that sort of proxying, we can actually inspect all of your SSL traffic. You don't end up with a situation where you have to do SSL bypasses just because of capacity issues that you might have on your firewall. Now, because a lot of our customers, we still have customers who may not have all of their SSL being inspected, but a lot of our customers do. And we see that 54% of all of the threats that we find is hiding behind SSL. And that's not surprising at all, because hackers are going to find the smallest thing that they can do to bypass your firewall. Either it's sending an HTTP message on a high port in a way that only a proxy could have detected the issues there, or it might just be encrypting it with SSL, and because you have SSL bypasses, now you're not able to look at that traffic. There is an 81% performance degradation when you start adding SSL inspection and advanced threat protection on your firewalls, and you don't have to pay. You end up with a traditional firewall having to pay that much more, or having to compromise on your security, versus with Zscaler, again, because your payment model is by user, you actually don't have to worry about that. And with increasing amount of SSL traffic every day, more and more sites are encrypting their SSL traffic. It is becoming more important to actually inspect that SSL traffic. Let's look at some of the types of policies that you can configure on Zscaler. You can configure policies by app. So you could say, for example, I want to block all of the P2P apps except for Skype for Business. You can do that by specific apps, or you can do that by groups of apps. You can configure policies for specific types of users. So you might say, I want to allow FTP only for IT users and no other users. You might want to, for a certain network segment, like you might say for your guest Wi-Fi, you're only going to allow HTTP and HTTPS traffic. Or you might, for example, have an application that is hosted now on Amazon that you're moving over from your data center to Amazon. It's now on a dynamic IP, and you want to have FQDN-based policies. So you can configure policies by all these different ways. And Zscaler, like I said, has an SLA-based guarantee for 6 months of all of the sessions, allow as well as block on your cloud firewall. What that means is, and also Zscaler does pre-crunch a lot of that into counters, so you get instant sort of reporting and drill down capabilities. So you could start looking at, for example, what are the applications being used, what are the most used applications, right? And you might be interested in understanding, or you might have an agreement with Box.com, and you might be interested in understanding if people are actually using Box.com or not. Also, you might see that maybe Box.com is not your preferred application, and there is a lot of use, and you might want to see which are the departments that are using procured cloud applications without, or have procured cloud applications without IT consent. You can then also drill down to specific users and look at that. And there are, you can do this drill down in multiple different ways instantly because, like I said, we pre-crunch a lot of that information for you in our logging. Because of that pre-crunched information, you also get a lot of widgets where you can look at what are the top applications that I'm using, and you can do charts around that. And here's another one that is extremely important for a lot of customers who are using firewall. Firewall policies tend to grow. They never get deleted. They just get added on. And sometimes you want to know, is this policy even being used or not? And so we have a widget that actually will tell you what are your top policies that are being used, and you can see which policies are not being used. And you could actually remove those policies or clean up your policies from time to time. The last thing I want to say is, yes, we've talked about a lot of cloud firewall functionality, but we have a stateful cloud firewall that does not have the next-gen functionality, but has everything else, including your elasticity, that is now integrated into the Zscaler platform. So if you have Zscaler, no matter what SKU you have purchased or what you have purchased, you actually at no additional cost have access to the cloud firewall. And that access gives you a unified policy across all of your locations or many of your locations. You can separate the policies by location, but you don't have to. Certainly you don't have to because of capacity reasons. And those are 5 policies, basically ports, protocol, and IP address-based policies. You get the single console or centralized management at no additional cost. You get the one set of logs. And in this case, you're only seeing the blocked sessions, not the allowed sessions, but you are seeing all of your blocked sessions at no additional cost for all of your outbound traffic. So again, let's look at that standard stateful firewall as well as the advanced next-gen firewall. The first one is available at no additional charge, no SKU, with your Zscaler platform. You can actually have 5 couple policies. You do not have app ID and user ID-based policies, but you do have location-based policies. You have limited dashboard functionality. You do not have the ability to configure DNS-based policies. So with our advanced firewall, you can actually say that you want to block or you want to basically sinkhole certain DNS requests, or you want to do IP lists that you don't want to have malicious. There are lists of malicious IPs that we already have in our URL filtering engine. And you might just want to say, I want to filter out anything that is going to a malicious server, or you might even want to filter out your, DNS requests for adult sites or illegal sites or things like that. For logging, you get full session-by-session logging, allow and deny for your advanced firewall, and you get logging for all of your blocked sessions only on your standard firewall. And my last question to you, this is a poll that we're starting right now. If you would like to try the Zscaler Cloud Firewall, whether it be the standard firewall, the stateful firewall that is already part of your platform and you'd like that to be enabled for you, or if you have interest in looking at the next-gen firewall, if you can answer the poll and let us know, that would be great. All right, thank you everyone for that poll. And if you were not able to get in your answer to that poll at this time, then you know, there is a survey that is coming up, and it would be great if you responded to the survey and let us know if you're interested in looking at either the free Zscaler Cloud Firewall or the advanced next-gen Cloud Firewall. Jen, are there any questions? I think we're at the end of the presentation now.
At this time, there are no additional questions, but let's open it up. And if anyone does have any questions, please go ahead and type them into the window at this time, and we'll do our best to either answer them online or follow up afterwards. We have about 5 minutes left. If anyone has any questions, we'd love to answer them. So again, type them in the Q&A window. It doesn't look like we have any additional questions, but if you do have any questions, please feel free to send them either to Shri or myself. Shri, could you give your email address one more time?
Sure, it is sri@zscaler.com.
And mine is jtoscano, that's JTOSCANO @zscaler.com. We thank you all for joining today and taking time out of your busy day to discuss transforming your branches and making and how you can make your next branch firewall a cloud firewall and why you should do so. So thank you again, and don't hesitate to reach out to us with any questions.